Right, let's get into this. So why do we check temporary works? The answer to this one is because there have been many failures of temporary works over the years. Many people have been killed by temporary works failures, and it's something that unfortunately it still continues to this day. We get failures of temporary works. I wouldn't say on a regular basis, but they do still happen. Probably one of the most high profile ones in recent years, one that certainly sticks in my mind a lot for the wrong reasons, is the Florida bridge collapse that's been built for the University of Florida, I believe. And when you read the OSHA report on the failure of the bridge, it makes fairly shocking reading. I think there's also been an IStruct presentation and TWF one by Steve Williams from Network Rail. He's done an in-depth review of this as well. And there's another one by a fellow from TGP. I think there's been 2 presentations that are worth watching. And if you want to go to the OSHA website, which is the American version of the HSE, and read their reports, what's good about the OSHA report is they don't hold back. They're not trying to appoint, or they're not worried about almost legal connotations. They explain very succinctly what they found and the issues that were involved with the project, and they act very quickly as well, particularly when you compare it to failures in this country where we still haven't got reports on failures that have happened over the past 10 years in the public domain, whereas in America it happens very quickly. So the highlights from that one was it was poorly managed on site. It was badly designed to start with. There was failings in the actual design of the structure, but the most pertinent ones, what we're discussing, is it wasn't checked in the temporary condition, despite the temporary condition actually being the worst load that structure was ever going to experience. And when you read through the OSHA document, you'll find the reason why is because the budget was too tight. So they cut the temporary conditions out, even though they had a legal obligation to undertake checking the temporary condition. It was cut out of the scope, and nobody actually looked at or considered that structure in the temporary condition. And then perhaps the most shocking thing of all in that is the cracks that led to this failure were actually discovered 5 days before the bridge collapsed. I still can't quite believe how they got to this point with a live traffic running underneath it and nobody stood up and said, hang on a minute, this is crazy. But there you go, it's a worrying one. So temporary works phase in this country, 60s and 70s, well, late 50s, 60s, 70s, there were quite a number of them. Barton Viaduct in Manchester, quite a few formwork and false work ones, which I think I touched on a few webinars ago now. We went through them. Fairly recently, 2016, that's a lift bridge in the temporary condition that failed just next to the Barton Viaduct in Manchester. So these failures are still happening regularly. Now, the collapses back in the 60s and the 70s led to what we know as the Bragg Report, written by Lord Bragg. And in there, he made, I think it was 27, was it 28 suggestions or things that the construction industry should investigate and should start doing. You can see 6 to 27 here. The ones that interest us in relation to checking are these ones. Interestingly, so this was written specifically for false work. We've now kind of extended the Bragg Report and 5975 out to take into account all temporary works. So where it says false work here, read that as temporary works. So one of the first ones there is that the initial design of any false work should be signed off by a fully qualified engineer, and alterations, significant alterations. That makes its way into 5975. If a design contains novel features, it should be checked by an independent assessor. Again, that is in 5975, or is it? It's certainly the Network Rail guidance. This one here is an interesting one, which we've kind of gone away with in the latest version of 5975. The false work designer should supply the permanent works designer with calculations for comment. In the latest version of 5975, it clearly states that calculations do not form part of the output. So that's an interesting one. I hadn't picked up on that today. That we've gone away from that in 5975, and there must be some reason for it, and I'm not really sure what it is. So the philosophy of preparing and checking again, and checking the design, of not modifying it without assessing the resulting effects, and of having any doubtful points checked. Again, talks quite a lot about checking in there, and that's all fairly well formalised in 5975. And the temporary works coordinator, whose duties are to ensure that all procedures have been followed, that all checks and inspections have been carried out. So TWC needs to make sure that the design and the check process has been followed. Right, why do we check? Sorry, I'm just going to have a bit of a problem with my screen there. Why do we, or it certainly seems to me that we pay a lot more attention to checking temporary works than we do permanent works. There are circumstances where permanent works might get Cat 3'd or what we would call Cat 2 checked, though I don't think it's quite as common as it is within temporary works. For permanent works, it's quite often just another engineer reviewing the calculations and the drawings rather than going away and doing their own independent assessment. But one of the reasons is with temporary works, there have been a lot of failures that have led to people dying, as I've said. Bragg Report tells us we should do. And when you think about it, or when you look at it, construction and demolition is fraught with issues as permanent structures in temporary conditions. These might be conditions or loadings that the structure has never seen before. We have comparatively large loads applied to temporary structures quite often, and they're not normally as heavily built as a permanent work structure. So large loads could be tower cranes, could be mobile cranes, piling rigs, stockpiled materials, all of these things. There's often a lack of information on the historical structure, so that's where you're dealing with an existing structure, obviously. Poor permanent works designs, which makes construction far more hazardous. If you've tuned into these webinars before, you'll see, you would have seen examples of this. There's often time and cost pressures with temporary works. Time to design it, time to construct it on site, program slippage on projects, cost of the design, cost of the temporary works. Temporary works are often missed out in the scope and the tender pricing for projects. So there's often those challenges there. A more recent one is probably extended supply chains leading to missed scope. So it wouldn't be uncommon for the principal contractor to appoint a subcontractor who appoints another subcontractor who appoints a designer. And there's quite a long way down to the bottom of that chain. And the designer at the bottom might have a very defined scope. So for instance, they might just purely be designing the false work, but they haven't looked at the effect on the existing structure or the permanent structure. So it's important that those little loopholes or those interactions are picked up. And again, that's made clear in 5975 through this idea of a lead design checker or lead designer for temporary works. So if you've got an extended chain like that, there should be somebody at the top who's responsible for ensuring that all of these items fit together, so that the person who's designed the false work, their design has been interfaced with the person who's checked the permanent works for those loadings, and that those two things tie together. So when you say the word checks or checking temporary works, people often jump straight to, oh, it's a Cat 1 or a Cat 2 design check. There's a lot more that goes into checking temporary works than just, oh, it's a Cat 1 or a Cat 2 check. There's checking the information provided in the brief. So that's looking at the brief, looking at what we've been provided with, and checking and understanding what it is we need to do as a designer. Checking the correct information is used in the design. So again, what has the brief told us? What do we know about the structure already? What other information do we have that we can use to facilitate the design? A massive part of checking to me is making sure the design looks right. If a design looks right, it stands a good chance that it is. If something looks wrong, 95% of the time it is going to be wrong. It's a very old saying that if it looks right, it is right, but it really does work in reality, and you can often spot issues just by looking at a design very quickly. A key part to me is this idea of checking what the design has done on paper feeds into what the drawings show. So in many design offices, you have the engineer and you have the draftsman. Now that straight away leads to an interface where what the engineer wants and has done has to be produced in the drawings. And we work slightly differently. We don't have draftsmen, we have engineers who do the engineering and they do the drawings as well, to cut down on straight away on that interface there. It's the way we've always worked, and it's the way we'll continue to work. It means that the person who's doing the design is also doing the drawing, and hopefully, or we believe, leads to a better product because there's no interface and you've got in your head what you're trying to achieve. And often when you're doing the drawing work, you spot something that would be slightly different, or you might do slightly differently to when you've done the design. Often the drawings and the calculations are done in tandem, which I think leads to a better solution quite often. Make sure the information supplied to the checker is correct. So that's about making sure that if the client has told you something after the brief came in, that you get that information to the design checker. If you don't give that information to the checker, I don't know how you can possibly expect them to know and take that into account. Perhaps you overuse the word check here, but I think you get the point that check is not just the categories of check. Check the checker is satisfied with the design. So once the checker's undertaken their design, they will give you feedback. Now that might be as simple as an email. It might be a DRN on a spreadsheet that can be formally tracked. But you've got to make sure that what the checker has identified is fed back to the designer, so you can agree on anything that needs to change or whatever needs to be done. When we get to site, we've got all of the checking the temporary work. So it's checking they're properly installed, check they're being used as intended, and quite an important one is check there's a methodology for taking the temporary works down. All of these things are identified in 5975, but that one at the bottom is probably the one that's most often overlooked. Making sure there's a way of taking it down when you're finished. So checking the input, we have this, it's not our saying, but GIGO, garbage in, garbage out. It's one of the things that we kind of spend a lot of time drilling into the more junior or the guys who've joined us more recently. Is you put the wrong input in, you're going to get the wrong output out. You can't but help. If you've got the wrong information at the beginning, what you produce is not going to be correct. And a lot of that comes back to the quality of the brief you're given. The classic with temporary works engineers is where the client specifies in the brief, we want to use RMD, or we want to use maybe, or we want to use MGF components. You complete the design using those components, you send it back to them and they say, oh no, we wanted to use such and such, even though the brief has requested one thing. It's time and money wasted. The brief document, it really is, to me, or to us, is the most important thing there is when you're doing design, and indeed when you're checking, because the checker needs to look at the brief as well and ensure the design complies with it. So the brief should be quite a detailed document. Now, it's obviously relative to the amount of or what you're designing, but it should highlight everything that the TWC or the project manager on site has got in their head about what they're trying to do, the constraints they have on the site, etc., etc. And it should be fed through so the designer could take that information, read it, understand it, and then use it. Correct information. So again, I've talked about this before. Tower crane loads, we've spotted a number of them that have mistakes in them, where the information that the tower crane supplier is providing is clearly wrong. And we've had quite a few of those over the past few years. That feeds into all of these though. So mobile crane loads, crawler crane loads. Mobile crane loads is one area that's quite often overlooked, particularly with larger cranes, is that the maximum outrigger load is quite often when the crane doesn't have its boom up, or it just has its boom up, but it's not lifting anything. So for a 500-ton crane, standard Liebherr 500-tonner, the worst outrigger load is 165 tons, which you get with the crane rigged with the counterweight slewed over one corner. That gives you the highest load you'll get, or it certainly generally does. Crawler crane loads, again, you can do almost a fag packet calc to confirm in your head that the figures you get are right. Pioneer rig loads is a bit trickier to review. With that, it's making sure you've got the right rig and you've got the right setup, but it's not quite so easy to check yourself. When you're looking at or checking your output yourself, the key thing as a designer is, if you're using software, does the deflected shape look correct? So if you're running an analysis model, you need to be able to look at the output and say, yeah, that's moving the way I would expect it to, or it's not moving the way I'd expect it to. What's going on? If you can't look at the deflected shape and understand it, then you probably shouldn't be using the software. Do the results make sense? Again, if you're using software or you're doing something by hand, you can often do a fag packet check the other yourself to confirm that the output is correct. Are the reactions as you expected? Are the stresses as you'd expect? You should be able to visualize a structure and have a good understanding of what you expect to see. And if your detailed analysis isn't showing that, then there's probably a cock up somewhere. Does the drawing look right? I've already been through this. If it looks right, it is right. Is it robust enough? So it's all well and good making something nice and lean, but it has to be robust at the same time. Temporary works gets abused. There is no doubt about it. It gets abused on site. So you've got to be efficient, but you've also got to consider the fact that these things will get abused slightly. Other one is to try and get a design out to the site team for them to look at it before it goes to be checked. Again, if they look at it and go, oh, hang on, I actually wanted to use maybe, but you've done it in RMD, you save the messing around where the checker has then checked the wrong materials as well. Always a good idea to do that. So the checking that you're probably most familiar with when we talk about checking is these check categories, 5975. They go from 0 to 3, with 0 being the least onerous, 3 being the most onerous. 0 is really for standard solutions, off-the-shelf products that you can use, and you're just basically looking at the instructions and saying, yeah, it complies with that. Category 1 is for fairly simple designs. We're going to go through some examples a bit later on, but the examples given here is formwork, needling, propping to brickwork, that sort of thing. So with a Cat 1 design, there should be a formal design undertaken, but the checker just has to be someone who hasn't been involved in the design. They can pick up your calculations, read through them and say, yep, I agree with what you're saying here. Good to go, sign the check certificate, job done. Category 2 checks is a bit more onerous than that, or quite a bit more onerous. If I did the design, or someone in the Chelmsford office did the design, ideally we would try and send it to one of the other offices for the checking. Not always possible, but ideally you would send it to another office where you can say with certainty that they weren't involved in the original design. And then what you issue them is the design brief, your design methodology, and the drawings. You don't issue them the calculations at all. Okay. Then the checker works from that input information, which is the drawings, the brief, and the kind of design methodology, and they do their own set of calculations to demonstrate that the structure works. So you should be receiving 2 sets of calculations, 2 independent sets of calculation. A Cat 2 is not a review of the existing or of the designer's calculations. Never has been, never will be. Category 3, similar to Category 2, except instead of another office, it goes out to another company. Interestingly, the definition in 5975 is another organisation. Okay, that will be interesting when we get to looking at the Network Rail definition, because it's slightly different to 5975. This is just a blurb that comes in 5975, which spells out certain items. I'm not going to read them out. Again, I'm going to touch on Category 2 and Category 3. The checker should carry out the checks without reference to the designer's calculations, using only the design brief, including associated information and the design output. Okay, it says it there in black and white. The number of times we see designs that are supposed to be in Cat 2 checked, and all they've done is they've read through the calculations and put their signature in the top right corner That's not a Cat 2 check. It can't possibly be, because you've looked at the calculations. The reason we do Cat 2 checking is because it's very easy to take somebody's design and follow through their methodology and say, yeah, well, that makes sense. Whereas if you take a step back and you have to think about the problem yourself from the basic input information, you will approach it in a different manner. Well, you probably will approach it in a different manner, and you will then be able to check the design separately. You're not going to follow what I'd call, say, down a rabbit hole and follow what the designer's done. So they might have made a silly assumption that seems reasonable, but by standing back and reflecting, you come to a different conclusion. That is the point in a check. It's not just to prove that everything's bang on. It's for you to sit and look at it separately and say, well, hang on a minute, have you thought about this? Most of the time, a Cat 2 and a Cat 3 will come back without any major comments, but the whole point is that somebody's looking at it independently and is thinking about it separately, not just copying what's already in the calculations. I don't know why that's blank. So within 5975, we have this what's it called, terminology, the implementation risk, which shouldn't be confused with the check category. Okay, I still can't quite get my head around this as a system, but the idea being that you can have something that's high hazard to build that is low hazard as a design check. Now, that might well be the case theoretically, but I'm yet to see it in practice where you have something high hazard, such as, I don't know, like a trench box that's being put in next to a railway or something similar to that. I've never seen in practice that would still get a lower level of checking, because although the design is still fairly simple, the hazard of failure is high. So I've always seen that people still want a higher level of checking than if that was just a trench box in the middle of an open field. So for instance, if you checked a trench box over here, it would be low on the implementation, might even be very low. No, probably low actually looking at that, on the implementation risk, and you'd probably get away with a Cat 1 check. It might even be Cat 0, but the chances of you being able to do it in here next to network rail infrastructure, implementation becomes high, but in practice, I would say that the check level would also become high. So although the 5975 says these two things are supposed to be separate, I don't believe that's how it's working in practice, but I'll be interested to hear what anyone else has to say from their own experience. I'm not seeing it currently, but there you go. Right, so network rail also identifies check categories themselves within Civ 003, which is now on issue 7, I believe. Fairly similar, though there are some slight differences to 5975. So Cat 0, same design team, different member of staff. It's a review. There's a little bit more guidance there, but nothing drastic as a change. So it says there, Cat 1, the checker may refer to design calculations and the assumptions. The checker shall assess the validity of the designer's assumptions. Yeah, fine, very similar to 5975. Then we get to Category 2 and Category 3. Interestingly, in 5975, the definition of a Cat 3 checker is a separate organisation. In Civ 003, it's a separate legal entity. Now, that's not much of a change, but the way I understand that is that there has to be a completely standalone organisation, i.e. there's two separate PI insurances in place, is the way I've seen it, and it's been discussed in the past with Network Rail as to what that clause means. So if it's a larger organisation, they hold one PI policy, but there's almost, let's say, 2 trading names, you can't do a Cat 3 check because it all comes back to the same legal entity at the top. Whereas if it's 2 entirely independent companies, that clearly falls under the definition of a separate legal entity. Guidance is fairly similar, but again, design checks should be carried out without reference to design calculations. I'm going in black and white there for category 2. The design check methodology and analysis shall be independently derived against the common set of design criteria. Again, it's a little bit slightly different the way it's worded. CIVO 03 does go into it in a bit more detail in here, specifically as to what they want to see for Cat 3 checkers. And interestingly, Network Rail specifically asks that the software is identified in the checker's statement. I think that's to make sure you don't end up with designer and the checker using the same piece of software, which not ideal, does happen, but ideally you would use 2 different analysis software if you could. That's not always possible because some software there's only certain things they can do. Again, you can read all this yourself, but the key point to take away is they expect the category 3 checker to come up with an independently derived methodology. Okay, it's not, you shouldn't just be looking at what the designers put in the design statement and just following it. They want you to think about it differently to ensure that you've used a different methodology and that Cat 3 check is okay. So people often want to know what these different categories mean. And how you categorize things. And I guess the simple answer to that is you have to use your judgment. It's not necessarily something that can be written down in black and white, though I am just about to attempt to do exactly that. However, these are examples. Okay, I don't know your site constraints. I don't know anything about your project. I don't know about the competence of the people installing it, etc. You need to look at it yourself and decide what category of risk it is. Okay, and as I've said there, I'm not a fan of tabulating it and saying, oh, this is automatically a Cat 1 or a Cat 2 or a Cat 3, because it depends on lots of things. So category 0 check, a simple thing like a trench box. In fact, many suppliers now have off-the-shelf design packages available for these. That clearly identify when they can be used, when they can't be used, what the surcharges are, what the maximum pressure is, and it's a simple case of taking the instructions for the trench box and then looking it up and saying, yep, I comply those constraints. Job done. Someone else can then look at those calculations, or it might not even be calculations. It might be as simple as identifying in a brochure what you're using and why, and then agree that it's okay. There are plenty of other trench boxes available. I just found a nice picture of an MGF one. There's loads and loads and loads of suppliers. Anyway, so within CIVO 03, Network Rail have listed out a series of items they consider to be Cat 0, which again you can read there. I'm not gonna read through all of them. Just going to pick out some interesting ones. So site hoarding only needs to be Cat 0 unless it's on a platform. Edge protection where it's for construction organisation, that's fine. Ground support for scaffolding, so foundations for scaffolding, where it's fairly obvious it works. Shallow trenches not exceeding 1.2 metre deep is their cutoff. Cat 1, something simple like needling through a wall, a masonry wall, something along the lines of what's shown to the right hand side there. So for that, you'd probably expect to see some formal calculations done for loadings, checking deflection, checking loads on components, etc. That can then be reviewed by somebody in the same team, though not someone who was involved in the original design. Okay, and you should be looking for them to go through the calculations and sign off and say, "Yep, job done. I'm happy with that." There should be a signed check certificate still for Cat 1, and if there's any queries, you just raise it directly with the designer, and then you resolve it between yourselves. Cat 1's normally an internal check or within the same company, so it should be fairly easy to resolve any issues between yourselves, I would hope. Otherwise, something's probably gone wrong. So network rail, again, their definitions are here. You can do formwork, single-sided formwork up to 2.4 meters high. Mobile crane, outrigger foundations in good ground for up to 50-ton crane, and that definition, that 50-ton crane is a mobile crane can lift 50 tons, so not a very big crane at all. Hoardings and fencing greater than 2 meters high falls into this. Reinforced soil structures with a retained height not exceeding 3 meters. Cantilever soil retaining structures, so sheet piles not exceeding 3 meters. Hoardings on a platform below 2 meters high. Interesting, that one. I'm quite surprised at hoardings on a platform get into category 1, but there you go. There you go. Category 2. An example of this was a fairly simple demolition scheme where there was it wasn't in a possession, there was nobody going underneath the structure. It was all on a construction site on a disused road, no time constraints. So it was a fairly simple piece of demolition that really consisted of working out the weights of the steels and then lifting them down piecemeal with a bit of propping in the middle. A little bit of stability as you worked your way into the structure, but nothing too complex. The designer should have produced, or did produce, drawings. You can see excerpts from them there, and they produced a design methodology or design statement, depends how you want to call it, and that was issued to Cat 2 checker to undertake a Cat 2 check. They didn't look at the calculations, they worked from that information, and at the end of it, they gave them a signed check certificate and a design check statement to explain how they'd undertaken the check themselves. And there should be now 5975 requests a document review notice, a DRN form for Cat 2 checks. So that just formally records what was identified as needing to be changed or needing further discussion with a checker, with a designer. So in category 2, Network Rail have quite a lot more information or options in there. So underpinning gets into category 2 checking, barge mounted equipment gets to Cat 2, facade retention schemes goes into Cat 2, conventional tower crane bases is Cat 2, temporary station platforms, tube and fitting, scaffolding not supported on the ground, demolition of single span masonry arches, the single span being the important part there. Anything above that gets into Cat 3. SPMT platforms, so that has to be agreed. Cat 3 is where you get into the more complex. So for instance, Churchill Way that we did, that was all Cat 3 checked. It was a mixture, actually. It was a split between the temporary works was checked by one person and the permanent structure in the temporary condition was checked by another, with the interfaces picked up by them as well, i.e. checking the prop loadings that were then used in the checking of the temporary work. So, and the reason that was done is the competence of the Cat 3 checkers. We needed somebody who had a good or a demonstrable track record of analysing post-tensioned concrete to satisfy the Highways Agency. So they did, I think it was Bramble did the Cat 3 checking on the structure, and then the temporary works was checked by Moreland. There you go. So that was clearly a different organisation to Andon, us who did the design. The output that was issued was, in this case, was actually an AIP, drawings, our design statement, and the brief that we received. That was all issued out for check-in. And the output that came back was an Excel sheet with comments from Ramboll, eventually signed check certificate, and in that case, the Highways, the AIP check certificate, and their design check statement explaining how they'd done it and what they'd looked at. So within Cat 3, there's quite a lot of information, or quite a lot of tasks or projects that Network Rail consider become Cat 3. There's some quite large catch-all ones, such as unusual concepts, bridge erection schemes, demolition of multi-span masonry arches, demolition of non-masonry bridges, partial demolition or modification of existing structures, underpinning in poor soil, complex or suspended tower crane bases, boring or driving of tunnels, abnormal stress cases in permanent works resulting from temporary conditions, any use of the observational method for geotechnical works, work on sensitive clays, interesting one, demolition plant operating on a suspended slab where more than the immediate bay floor is vulnerable. That's an interesting one. So that pretty much means any structure where you've got more than one story, I guess. Use of existing structure as anchorage for cutting away and lowering large steel or concrete sections. Projects involving partial demolition of brick or masonry arch structures or partial dismantling of steel and concrete structures where stability of retained elements could be affected. So there's quite a lot within here talking about demolition or partial demolition. I think that's they've added a bit more since the previous revision of CIP 003. And there's some explanation notes under there, but again, it gives you a good idea of what might fit into which category. But as I said, it's up to you to decide yourself which is which. So I've added this clause out of 5975 here. Neither the designers nor the design checkers calculations form part of the design compliance items listed on the signed design certificate, which is, as I said earlier, this is in contrast to what it says within the Bragg Report, which is interesting. And I also know, in fact, we've had a discussion on these webinars previously with Network Rail, Stephen Williams and Network Rail. Network Rail pretty much will always want to see the calculations. And the reason being, as Steve explained to us before, is because it picks up a number of times major failures have been picked up by review of calculations, which is why they almost always insist on seeing the calculations. Many other clients do as well, interestingly, even though we don't have to issue them, many clients will insist that they're issued before they'll accept the package. So if you're doing a design check or someone's checking your work, 5975 sets out in there what should be done if there's differences of opinion between the designer and the checker. As I said, as I've been going through category 0 and 1, you just have raise it directly with the designer and resolve it before it's issued. For category 2 and 3, it needs to be more formal. So for category 2, scheduled queries should be prepared and issued to the designer and copied into the TWC. You shouldn't be copying in chunks of your calculations, although it's okay to show output from your calculation. So for instance, you've run analysis and you found that, I don't know, what's a good example? A pile load is higher than the designer has said. You could indicate that in the design review notice, so people understand what you found and where. But you shouldn't include the calculations as to how you got to that load. Does that make sense? You can say, well, I've actually got this load in this member here, whereas you're saying it's this load in that member. We need to resolve and understand why we've got there. For category 3, loads, idealized structures, soil parameters, etc., should be identified in an AIP or similar document. So that's formalizing the requirement for a design statement, which basically sets out what the designer has done and how they've done it, without going into the detail of the calculation. So you should be able to pick up a design statement, read it, and understand exactly what the designer has done without having to look at their calculations. And that should be agreed with the client's technical team before it goes out. And that should form the basis of design and checking. Again, that's referred to within the CIP 003 procedures. For Cat 3, the DRN notice, document review notice, should be prepared and should be copied to TWC and to the designer. Again, don't refer to calculations, but refer to things you found in your analysis. Okay, so again, there's guidance out there, but that is the point. So what should you expect as a Cat 2 or Cat 3? You should get an additional set of calculations produced independently. Okay, regardless if it's Cat 2 or Cat 3, you can't have a Cat 2 check without someone doing their own calculations. It's written down in black and white repeatedly. Ideally, you should use a different approach or different software. Not always possible, as I've said, but ideally, it's not a review of original calculations. The Cat 3 check should not be full of caveats. The Cat 3 checker is signing off to say that they are happy with the design as shown. You can't do a Cat 3 check and then fill it with so many caveats that it's worthless. That isn't a Cat 3 check. It's just nonsense, and we see that every now and again where someone does that and just put so many caveats in the check certificate that it makes no sense. The checker is saying they are satisfied with the design. That's it. There's no ifs, no buts. You are saying, I'm satisfied with this design. If you're not, you shouldn't be signing the check certificate. The Cat 3 check is not someone proposing another design. That is not the point in a Cat 3 check. The design has been proposed. The Cat 3 checker is checking it. They're not there to try and say, oh, why don't you do it like this? It's too late. Any concerns or issues should be clearly identified through the document review notice. It should be dealt with amicably. It's not, for want of a better description, a pissing contest. It should be professionals sitting down and discussing, or not discussing, writing down in the DRN what the issue is. And if it proceeds to a meeting, it's there to try and resolve the queries. It's not to try and outdo each other. TWC should be involved with the review process. It may be necessary for designer and checker to discuss, and formal records of that should be maintained. Again, calculations do not form part of design output, though you will often be requested that they are delivered. So as an example of what you are looking for at the end of this is our standard temporary works design and check certificate. You should know who the designer is, should be signed, dated, should refer to the drawings produced with a revision. Loading constraints, if they can be described easily, put them in there. If not, it's just go and look at the drawings. Proposed category of check, we always put that on there because it might not necessarily agree with what the TWC has said. But there you go. The codes we've used, other literature that's been referred to. And similarly for the design check, it should say what level of check's been undertaken, does it comply with the brief, and it should all be filled in and signed off exactly the same. Important thing to consider is listing out the documents and drawings utilised, because these form A, it forms a record of what you've used in your design, and B, it allows the checker to understand the input information that they might need to look at in order to complete their check. Checking temporary works on site. This is the next kind of big check in the loop. TWC or TWS, if they've been given the authority, can sign off the permit to load. They must be happy that design has been accurately translated into reality. That's what they're saying. If the reality doesn't reflect the design, the designer and the checker should be notified, and they should confirm they are happy. Excuse me. And the design check should be completed prior to loading. It doesn't really help you if the Cat 3 or the Cat 2 check is completed after the temporary works have been loaded. What if they pick up an error that needed to be rectified? A great example of lack of checking on a temporary works on site is this. Hopefully you can all spot it, but it's the U head here, which hasn't been loaded centrally. The alley beam on top there is clearly eccentric and is suffering somewhat. Another great example of checking. No need for the high yield steel pin for this push pull plumbing up a prop. Nope, just a bit of all thread rod. That'll do nicely. This one's kind of a warning of people writing briefs, perhaps, to think about everything on a project. So the brief was designer formwork for this side of the structure, so the site side, but the TWC didn't flag up the fact that the back side was a masonry wall like that, and then they proceeded to pour a massive head of concrete against it and were surprised that the wall fell over into the garden next door. Right, that's enough of that, and we are running out of time rapidly, so it should just about be okay. This is a short case study on the Army and Navy flyover, which is a job we completed a little while ago now. I can't remember the years, probably 2 or 3. If any of you are familiar with Chelmsford, you may well remember the Army and Navy flyover. It made traffic flow in Chelmsford so much nicer than it is currently. It was a flyover that allowed the A114 to carry on into Chelmsford. It was bi-directional, so when traffic was coming out, you went this way. When traffic was going in, it went that way. And they had big signs to shut it off either end. Didn't stop a number of people crashing head on top of the structure, but you can't help stupid, can you? Right, that was the structure kind of in a nutshell. It went straight up and over the roundabout as a flyover. It was originally built as a temporary structure back in, I think it was the 70s. So it did fairly well to last into the 2000s, quite a long way into the 2000s. Unfortunately, the hot summer we had, which I think might have been 2018, might be 2019, whichever one it was too hot and the structure couldn't deal with the expansion. And as it's on a radius, as it expanded, it actually tried to rotate and lifted 2 of the legs. And at that point, the council made the decision that, you know what, this is life expired, which is unfortunate because I said it made a hell of a difference to the traffic flow in Chelmsford. Just giving you an idea of it. So it's an approach ramp either side, then a fairly level piece across the top over the roundabout, and then quite a steep ramp back down the other side. So it wasn't the most complex piece of demolition we've ever been involved with by a long stretch. Not a great deal to do. The key things to consider really was stability of the structure as it was dismantled, weights of components, because it was all going to be taken apart by lifting it, and also considering the constraints of the site. So you've got subways, you've got an old culverted river, there are any number of different things in the ground, and also rather interestingly, the soil in the middle of the roundabout was probably the softest thing I've ever seen with a plate bearing test. So I don't quite know why, but it really was incredibly soft. So the proposal was to work our way out from the middle in both directions, avoiding all of the things in the ground that we needed to, and the design of a working platform there on the roundabout to facilitate the crawler crane operating. It was probably the closest job we've ever done to the office in Chelmsford, which was quite nice. And at least the site visit was only 5 minutes away, which made a big difference. So there was the assessment of the subways and also the culverted river. The culverted river wasn't a problem. It was the subway itself. When we analysed that, you could track the crane over it, but you couldn't operate the crane next to it. And we didn't really need to, so we established the exclusion zones, and that was it for those. Working out the weights, as I said, so the sort of the heaviest lift was 34 tons, and then it was purely working our way out from the middle, back across, stability for some of the piers that were to remain in place while the road was open, which was just a simple propping system. And then the reason I chose it as a case study is it's actually quite a nice video for a change, which doesn't happen all the time. So yeah, getting ready to cut them free, lift out the spans individually. It goes 2020, it was taken down. And just burning the bolts there to release the pieces. And it pretty much was taken apart the way it was put together. You see one of the subways there. And they actually transported them pretty much each section in one piece. They took it to the CDC's yard in Ipswich, and it was broken up there. Okay. Back to CDC's yard. And smashed up. And recycled. The biggest span there, the 34-ton ones there, were the ones over the road. The last bits are broken up in situ. Not much more we can do with them. Okay. I'm not sure why it was a crucial step, because as I said, it's just made the traffic flow atrocious, but there you go. There we go. That is the end of the presentation. That's pretty bang on. If you want to know more